Hello guys, thank you so much for being with me in another artificial neural network tutorial video. We go to another classifier. Again, the W matrix has been multiplied by the input vector and the scores that have been obtained. The idea is very simple. We want to turn these points into probability. Probabilities have two important features. First, their values are all positive to absorb the negatives. We make all of these positive by exponentiation. The second characteristic is that the sum of the probabilities is always 1. To realize this feature, we must use normalization. We call the function that does this for us softmax function. For this reason, in some cases, this new cost function is called softmax function. That is not true because only softmax was used here. Now, what is the benefit of this work? In this way, we can focus on the score or probability of the correct class. We must maximize the probability of the correct class. The maximum probability is 1, and when one of the probabilities is maximized unconsciously, the rest becomes 0. The ideal situation is that the probability of the correct class is 1 and the probability of the remaining classes is 0. The output is a one-hot encoding. You are familiar with this concept in the machine learning course. This coding method states that 1 is a 1 and the rest are 0. This is the cost function that we want to minimize. The value of the cost function for the whole data is equal to the sum of the value of the cost function for each function. We said that at the starting moment, W are very small random values close to 0. So the points will be almost 0. So in this formula, e to the power of points is almost equal to 1. So the denominator will be almost equal to the number of classes. After mathematics, we know that we can say by applying this negative that at the start moment the cost function is equal to the logarithm of the number of classes. So at the moment of starting, we can roughly check the cost function. If it follows this rule, it means we can trust this cost function. Otherwise, we have to think about defining a new cost function. Because if the cost function is not suitable, all future calculations will be useless. The lowest value of this cost function is 0 and the highest value is a positive infinity. The hinge function is similar to the ReLU function. For simplicity, we have considered 4 features instead of 3072. Here, each row corresponds to a class. In space, each of these levels give us a line for classification. Each line is a classifier. The cost function finally gives us a number. The lower, the better. The more it is, the worse it is. Where to use which cost function depends on the problem. Of course, I will provide a comparison of these two. To compare these two functions, we slightly move this vector x in space. What effect does this have on these two cost functions? You can see that in this case, the SVM cost function will not change much because the exact amount of points is not very important. SVM is not very sensitive to the exact amount of points, but this is not the case with Softmax. The sensitivity of this function to the exact values of these scores is higher. Thank you so much for being with me in this tutorial video. Have a nice time.